All right, and then our last internal processes I want to talk about is tectonism. And this is about deformation or breaking of the Earth's crust, or folding and faulting of rock. So especially where we have plate tectonics, where things are coming together, being pulled apart or being pushed side by side, we have pressure that's acting on rock, including compression. Rock can be compressed. Two things can happen with compression. The rock can break and slide up and down, or it can, in some cases, even be folded. We'll talk about folding towards the end. We also have tension, where rock is being pulled apart from each other. And where that can happen, some of the rocks get uplifted and some of them slip downward. And lastly, we have what's called shear force. This is where rocks are sliding past each other. Best example of that is the San Andreas Fault. So one thing that can occur when you're put rocks under stress is they can fault. Faulting is where the rock structure is broken and one side is forcibly displaced. So here, not only are they broken, but one side is up and one side is down, one has slipped down and one has been pushed upward. This is a process called faulting. There are different kinds of faults. A normal fault is caused when you put rock under tension. You're pulling it apart and one is uplifted and one slips downward. You can also have what's called a reverse fault, where as you push rock together, one is forcibly pushed upward and one slips downward. You can also have an overthrust fault. This is where rock is being pushed together and one piece of rock is shoved up and over the other. And lastly, you can have a strike-slip fault. This is where shear force is displacing the rock in a sideways motion, like along the San Andreas Fault. So some of the result of this is that rocks can be, you can have a tilted fault block. So here, this is a fault, and this whole slab of the Sierra Nevada has been tilted upward. So here's a side view of it. And as it tilted upward, that exposed a lot of the granite underneath the ground because the stuff on top of it eroded away and exposed the batholith underneath. Behind there, you also have what's called Horst and Graben landscapes. This is where you have fracturing, where as you pull areas apart, some of the rock can be displaced downward, some of it is slipping upward. So in the area called Basin and Range behind the Sierra Nevada, you have what's called a Horst and Graben type of landscape, where you have strike-slip faults, like along the San Andreas Fault. You can end up with a linear depression or linear trough called a linear fault trough. And this is a depression along the ground. And one thing that kind of gives it away is in some places you have streams that come up to the fault and then take a turn and then zigzag away again. So here you can see streams that have been moved along over time as the Pacific Plate has sort of crept its way northward. And you can actually see the fault underneath here. Here's another view in this area called the Carrizo Plane, which is just west of Bakersfield. This is a dry area without much vegetation. You could literally see the San Andreas Fault as this linear trough on the ground. So on this side, the area is creeping northward. On this side, it's staying put. So you can see some of the streams don't quite meet up where along that trough. Now, if you're pushing rocks together, you could also have folding. This is where you have, for example, these sedimentary layers are put under pressure, under compression, and they can be folded up together. This creates two types of features, one called an anticline, this is the overfold, and a syncline, an underfold. One thing significant about these is they're often associated with areas of oil and gas production because the folds can create traps where you can collect gas and oil, and those can be tapped into to extract oil. So just to end, in California we see a number of examples, especially with the movements of the San Andreas Fault, where rock can be uplifted and tilted. This is the Devil's Punch Bowl in Antelope Valley. These are sedimentary layers that have been kind of uplifted sideways. These are the Vasquez rocks in the San Gabriel Range, where these are other sedimentary layers where they've been kind of uplifted and tilted upward. These are both examples of tectonism.